This is a traffic flow equation, and then that equation is measured in cars per minute. So for letter A, remember the integral is an accumulator. It says how many cars pass through that intersection over the 30-minute period. This is cars per minute. So when I integrate that, that'll give me just the cars, and it'll add up the first 30 minutes for me. So just do math 9 with that function between 0 and 30. Usually we round to 3 numbers after the decimal, but since it says to the nearest whole number, that's why I stopped at 2474 cars. Part B, it says, is the traffic flow increasing or decreasing? Now, understand this is the traffic flow. So they want to know, is that increasing or decreasing? And so if we want to know if anything is increasing or decreasing, we want to know if its derivative positive or negative. So I need to take the derivative of that at 7 and then determine whether that's a positive or negative answer. Remember, Math 8 will do that for us. If you're on the calculator part of the test, which this is, and you're supposed to take the derivative at a particular number, Math 8 function will do that. If you need a refresher on how to do that, rewatch the graphing calculator video where I show you how to utilize that Math 8 function. You can actually take the derivative by yourself on this one and plug in 7, but I would just Math 8 that function at 7, and then it gives you that answer. And then since that f prime of 7 is negative, that means that traffic flow is decreasing at t equals 7. Letter C and D is just two straight things straight out of your blue packet there, okay? You have in your blue packet, I believe on the second page, an average value formula and an average rate of change. Boom, boom, back to back, so you know the difference between the two. So when you see average value, use your average value formula. So I did 1 over 15 minus 10 times the integral from 10 to 15, and then math 9 that thing right there. I would probably put the 1/5 in there first, then hit the math 9 between 10 and 15. That way you don't have to worry about it at the end. It doesn't say to round that 1 to anything, so you round to 3 numbers after the decimal. Whenever you use the average value formula, the units will always stay the original of whatever it is that you're integrating right there. Like when you integrate cars per minute, you get cars, but then you're dividing it by the 5 minutes again to get the cars per minute. So when you integrate average value, it's just averaging stuff out. It means on average, there's almost 82 cars per minute flowing through that intersection right there. So again, when you use the average value formula, always keep it the same units. And as those units are, it tells us is in cars per minute. So it's going to stay cars per minute. And then letter D is your average value formula. And then that's this guy. It's just your slope formula. F of B minus F of A over B minus A. So F of 15 minus F of 10. So you got to take the 15 and the 10, plug them into that function, get the y values, divide it by 5, get you that number there, round to 3 numbers after the decimal. Now it does say indicate units of measure. So on this one, you're doing the slope of this function, which is like the derivative of this function. So this was in cars per minute. To me, that's like a velocity. So when I do a derivative or slope of that, it's going to switch it to like an acceleration, which would be cars per minute squared. That's what we got right there. And then your F units are cars per minute on the top, and you're dividing it by minutes again on the bottom to get that minute squared in there. Trucks.